Hi, and welcome to the videos for section 1.8 for Math 126. This is the first of 3 videos. In section 1.8, we're going to be looking at coordinate geometry. So when we're talking about coordinate geometry, we're talking about graphing, and we're talking about the XY plane. So the official name, the coordinate plane, as it makes sense, right? We have X coordinates and Y coordinates. Or you may also see it called the Cartesian plane. So either way it's described, coordinate plane or Cartesian plane, we're talking about a graph that has our X and Y axis. X-axis is our horizontal values, negative left, positive to the right. And then our vertical is our Y-axis. So we will be given 2 numbers called an ordered pair. The first number is our X value, that tells us do we go left or right. Second number is our Y value, tells us do we go up or down, depending if it's positive or negative. This, in the upper right, this is known as quadrant 1. So actually, let me write it out so we know. And in quadrant 1, what is our X and Y values going to look like? Well, the X is positive, Y is positive. So we're going to have an ordered pair that's a positive number, positive number. That should put us in quadrant 1. That starts in the upper right, and then we move counterclockwise to quadrant 2. And this values are what? Well, X is negative coming to the left and we're going up, so it's going to have a negative number and then a positive number. Continuing around, we're in quadrant 3. Now these are what? X is negative, we come to the left. Y is negative, we go down. So it's going to be a negative number and a negative number. And then lastly, quadrant 4 is in the lower right. And it's what? Well, X is positive, we're moving over to the right. And then we're moving down, so it's going to be a positive number and a negative number. Where these two intersect, this is known as the origin. And this has coordinates what? 0, 0. We don't move left or right, we don't move up or down, so 0, 0. So that's our coordinate plane, some of its properties. In this chapter, we're going to be looking at graphs of equations, or in this section rather, in 2 variables. And so we have the following definition. The graph of an equation with variables x and y is the set of all points given the form parentheses x, y in the coordinate plane that satisfy the equation. So what does this mean? So i.e., for example, let's say I have the equation y is equal to 2x. So I can pick values for x, and that'll calculate some value of y for me. So if x is 0, so we have our form here, the ordered pair. If x is 0, what's y? 2 times 0 is 0. So that's a point. What if x is 1? Well, 2 times 1 is 2, so y would be 2. What if x is negative 1? So negative 1 times 2 is negative 2. So we'd have the ordered pair negative 1, negative 2. And we could do this infinitely many times, right? I could pick x as a half. I could pick x is 10. I could pick x as negative 30. No matter what values I pick, fractions, decimal, I could pick whatever, negative 10.332. And that would give me some value for y. And I could do that all day long. Well, what that does is what? It generates a graph we have 0, 0. We have 1, 2, which means we move 1 unit to the right, 2 units up. Or negative 1, negative 2. Negative 1 to the left, 2 units down. And then I connect these dots with a solid line, an arrow on each end, meaning it goes on forever. So literally what this line is on the graph is every single point that satisfies that equation. I can't write out an infinite number of solutions, but by drawing this graph, that's what I'm doing. I'm saying that any point that's on this line satisfies that equation. And that's what a graph of a line is really telling us. So let's look at an example. I guess a more formal example than what we just did there. But basically the same idea. So we want to draw the graph of 2x minus y equals 3. We want to do this by plotting points. Now, I'm underlining plotting points because whether it is in this class or whether it is in Math 127 or if you go on to Math 181 or any class that you have to draw a graph, you're going to learn shortcut techniques. Graphing with slope, or in 127 doing some polar graphs. So how do you do it? But ultimately, if you don't remember the shortcuts of how to draw lines or draw curves, you can always come back to this, plotting points. Build yourself a table, calculate the values, and then just plot them on the graph and connect the dots. So when all else fails, remember you can plot points. So to do this, the first thing we want to do, just as we had over here, y is equal to something. So that then we can pick our values for x and it'll tell us what our y value is. So for first step, we're going to solve for y, meaning get y by itself. So to do that, what do I have to do? I have to, so let's do 2x minus y is 3. So if I add y to both sides, what do I get? 2x is y plus 3. And if I want y by itself, I need to subtract 3 from both sides. That gives me what? Y is equal to 2x minus 3. So now I'm going to build the table. And I would pick, unless you're restricted, because you guys remember we were talking about domain. So obviously, my domain for this equation is what? It's all real numbers. I don't have a radical, I don't have a denominator. So I'm going to pick a couple positive numbers, and some negative numbers, some positive numbers. So let's actually go -2. The more numbers you pick, the better the curve you're going to get, or the line you're going to get. And so when we start doing curves, you're going to want to pick some positives, some negatives, 0 if you can. Let's see what we get. So with -2, when I plug that into here, so 2x minus 3, which is my value for y, we get what? 2 times -2 is -4. -4 minus 3 is -7. So one of my ordered pairs that I'm going to graph by plotting is -2, -7. How about -1? So 2 times -1 is -2, minus 3 is -5. So I have -1, -5. If I plug in 0, 2 times 0 is 0, minus 3 is -3. So do you see what's happening with the numbers here? -7, -5, -3, So we would expect this to be what? -1 and then what? +1, right? But so for here we have -3. Let's check. 2 times 1 is 2 minus 3 is -1 as we thought. And this one is going to end up being +1. So we have 1 -1 and 2 +1. So now to graph this, I'm going to draw myself a coordinate plane or an XY plane or a Cartesian plane. And you'll see that this is not going to be exactly to scale. If you have graph paper, it'll look, a lot better. But for now, we're sketching this basically. We're not saying it's an exact representation, but it looks like what we want. So we have what? We have -2, -7. So -2, the x, just like the alphabet, x comes first. So x, we go -2 to the left, and then down 7 puts me over here. -1, -5. So -1 to the left, -5 down. 0, -3. So 0 to the left or right. So I'm going to end up on the y-axis and down 3 units. Puts me there. 1, -1. So 1 unit to the right, 1 unit down. Ooh, that's really not the scale, huh? Let me make my dot bigger. And then 2, +1. So 2 units to the right, 1 unit up. And again, if this was the perfect world and I could draw a perfect graph, that is or would be a straight line, and should be a straight line, but again, not the perfect world here. But that's what it looks like. So every single point that is on this line is technically a solution to this equation. And so that's how we're graphing by plotting points. So that was what? That was a linear equation. We ended up with a line. What if, so I'm going to do another example here. So we're still going to plot points. We're just going to have a different equation here. So now we want to graph y equals x squared minus 2. So this one is no longer linear. The x value is squared. So let's see what this looks like. It's already y equals something. So we just need to build ourselves a table. So I'm going to go with -1, 0, +1. You know what? Actually, let me go with the same values we had before. -2, -1. Especially because we're going to have a curve here, I want to make sure that you guys see sort of how this looks. So when we have -2 for my x, then the y value is what? X squared minus 2. So -2 squared is +4. +4 minus 2 is +2. So our ordered pair is -2, +2. How about -1? So -1 squared is +1. 1 minus 2 is -1. -1. If I plug in 0, 0 squared is 0, minus 2 is -2. If I plug in 1, 1 squared is 1, minus 2 is -1. And 2 squared is 4, minus 2 is 2. So I get -1, -1, 0, -2, 1, -1, 2, 2. So if I draw this on my coordinate plane, we have -2, +2, that's up here. -1, -1, so -1, -1. 0, -2, so 0, -2. 1, -1. And 2, 2. So looking at this, if you're just connecting the dots, you might think, oh, this is a V. It's not a V. This here, this x squared, Anytime we have y equals x squared plus or minus any sort of combination, algebraic combination, this gives us a parabola, which is basically like an umbrella either turned upside down or vertically. So this actually doesn't have a point, it's a curve. Again, not the best drawing, sorry about that. But it's this, and this should be smooth, so not my best day drawing here, sorry about that. There we go. So it should be like a U, or like I said, an umbrella. Skinny umbrella, could be a fat umbrella, facing up, facing down, but it's always going to give us, when we have an x squared, a parabola, and you should get this sort of cup shape. So that's what we get when we graph this by plotting points. So I didn't even have to know ahead of time. I didn't even tell you till the end that it was what, a parabola. But we can still graph it just by plotting the points, and that's always your go-to if it's on an exam and you can't remember, like, oh, is this a parabola? Is it a V? Is it a line? What is it? I don't know. Just plot your points. It'll always get you what you need. So one more example. Let's actually do that. All right, so this one we're going to be graphing y equals the absolute value of x. So now we have our table again. -2, -1, 0, 1, 2. We'll pick the same values. So what do we get for our y value? Well, when x is -2, y is the absolute value of x. The absolute value of -2 is +2. -1, the absolute value is +1. 0, the absolute value is 0. 1, the absolute value is 1. 2, the absolute value is 2. So when we graph this one, we get what? -2, +2. -1, +1. 0, 0. 1, 1. 2, 2. So this one now does look like a V, and it in fact does give us a graph that looks like a giant V. So the difference between the parabola and x squared, which when you plot a few points might look like a V, but it's not, it's a curve like a cup, but the absolute value graph does look like a V, and it gives us a shape that looks like that. So, let's see here. I'm going to erase this graph. The last topic of this video has to do with intercepts. So the x-intercept what does that sound like? That sounds like the points where the graph intersects the x-axis. So let's say I had some graph, let's say it's a parabola. My x-intercepts, where's my x-axis? That's here, right? The horizontal line. So my x-intercepts, I actually have two of them. Two places where this graph hits the x-axis. So the x-intercept is the point, or points, depending if we have more than one, where the graph intercepts or intersects the x-axis. We can find these values by setting the equation y equals 0. So if I have an equation of a parabola, whatever, let's even just say it's a line. So let's say Let's say the first example we had, which was what, 2x minus 3. So we had a graph that looked like what? It was something like that. So if I want to find what is this point here, well, I just set this whole thing equal to 0 and then solve for x. So I get 2x is 3, divide by 2, x is 3 halves. So this point right here would be what? X is 3 halves, and y is what? Y is 0. I don't move up or down. So that would be the x-intercept for that graph. And how about y-intercept? Well, the same idea. It's where the graph intersects the y-axis, or intercepts the y-axis. And for this, well, and this is where it's a little bit confusing because it's sort of reversed. So if I want to find the x-intercept, I set y equal to 0. If I want to find the y-intercept, I set x equal to 0. And it's because what? Well, where it hits the y-axis, what's my value for x? It's 0. 0 doesn't go left or right, so I'm only stuck with the up or down portion. So we're going to find by setting x equal to 0. And we did this when we built our table. If I set x equals 0, so I have 2x minus 3. If x is 0, so it's 2 times 0 minus 3, which is negative 3. So this point is what? Well, 0, x is 0, y is negative 3. So that's my x-intercept and my y-intercept. So that's it. Sort of some basics. We got the coordinate plane or the Cartesian plane. We can graph anything we want by always plotting points. And then the intercepts. Where does the graph intercept? Where does the graph intercept the coordinate plane? So come on back. We'll look at a special type of graph, which is the circle.